Okay, so in the previous example, we moved a loop into a magnetic field, and the magnetic flux changed, and we evaluated the EMF, and the conclusion is that somehow this EMF is associated with magnetic force, but of course magnetic forces don't do work, so there's another force there that could do the work, which is us dragging the loop. But either way, there's no notion of an electric force or an electric field. But in an example where, for example, we have a magnetic field pointing everywhere out of the page, like this, but varying at a rate in magnitude dB by dt equals some k, where k is some positive number, then we could imagine some flux. Let's say that we have there's some symmetries here to deal with, but we won't worry about them now. So let's say we have a little loop of radius, say r naught, and so we have a magnetic flux, which when we integrate the magnetic field over the surface of this red loop, and we get B times A, which is B times pi r naught squared. We don't have what B is, but there's clearly an EMF, which is minus d phi by dt, and that is minus dB by dt pi r naught squared. And we know that dB by dt is k, so we have minus k pi r naught squared. And this EMF isn't generated in the same way that it was before, by moving a loop through a magnetic field. And so maybe we could say that this EMF is associated with an electric field. After all, an EMF is a voltage, right? So we could say that this is the result of integrating around the loop, integrating some electric field, which in this case would have to be constant everywhere around the loop. Right, so we integrate around the loop, the red loop, it's a closed loop. And so if we have a constant electric field, then this side looks like the magnitude of that electric field, right? It's pointing tangent to the red loop, times 2 pi r naught. And that is equal to, we're dealing only with magnitude, so let's forget about the minus sign. Let's integrate such that we get a positive quantity, and therefore k pi r naught squared. And so we would say that the magnitude of the electric field that's tangent to the red circle is k r naught over 2. That would be the magnitude of this electric field that's associated with the EMF. This would be an induced electric field. And just to comment on the symmetry properties, this is really a symmetry due to the origin. We sort of are thinking of producing this kind of magnetic field by a solenoid that is, it's an infinitely long tube that then sort of expands, and so the symmetry is always with respect to the origin. But we have the interesting thing that the EMF in the previous example was clearly associated with magnetism, magnetic fields, whereas in this case it's associated with electric fields. And this will lead us to the ideas of special relativity.